Here we have a picture of the Earth's magnetic field. We're going to be able to view this from zooming out and taking a look at our place in space relative to the sun. That's constantly streaming charged particles towards the Earth. You'll find that those particles get deflected, those charged particles get deflected from the Earth's magnetic field, and they find themselves heading to the poles. And we see this result in the form of auroras, which we find in the northern hemisphere, called the Aurora Borealis.
The sun is a star, like the other stars we see in the night sky. It's much closer though, so it looks different, like a gently glowing ball. But there's nothing gentle about the sun. Those dark patches are sunspots. Each of them is about the size of Earth. Sunspots look dark because they're the coolest places on the sun, only about 8,000 degrees Fahrenheit. The rest of the sun is even hotter. The sun's energy, like that of all stars, is created by collisions between tiny particles called protons. Every second, countless numbers of protons collide and fuse within the sun's core, releasing incomprehensible amounts of energy. Most of this energy leaves the sun as light. Some of it leaves the sun's surface in a continuous stream of charged particles known as the solar wind, which blows out into the solar system at almost 1,000,000 miles an hour. Or in less frequent but faster solar storms that blast particles out into space. We're looking at actual images of solar storms taken by a NASA satellite. See that static? That's a solar storm cloud hitting the satellite and overwhelming its imaging device. The solar wind blasts across the planets in the solar system every second of every day. It's so powerful that contact with it would sweep away a large portion of our upper atmosphere, removing much of our water and dramatically altering the development of life on Earth. But fortunately, Earth is protected by an invisible natural shield. What you're seeing is a visualization of Earth's magnetic field. This field arises from Earth's iron core, which makes our planet act like a big magnet, attracting some things and repelling others. Wrapped in this cocoon, Earth is sheltered from the solar wind. But some of the particles make it through this magnetic barrier, eventually reaching the North and South poles. The results are spectacular. Glorious, shimmering curtains of color. This one is the Aurora Borealis, the northern lights. Auroras occur when charged particles from the solar wind and solar storms collide with the upper atmosphere of Earth, causing atmospheric gases to glow. That's the International Space Station, circling the globe in low Earth orbit, about 250 miles up. Not many people have seen the aurora from out in space. The collisions that cause auroras happen between 60 and 300 miles above the surface of the Earth, far above where airplanes fly. And create one of the greatest natural light shows on our planet.